Alright, on day 2, this can be some difficult integration problems, so we just want to keep that in mind. We're going to do some different things to come up with our answers. Well, our goal is to always have that a squared u squared or a squared plus u squared or this u squared minus a squared. So we're looking for those types of things. If you look here, I don't have that. And if I try to integrate, this isn't going to work out because it's all to the negative first power, and I couldn't make a u statement because it would create a lot of mess. So we've got to look at this just a little bit differently, and we're going to go back and pull some things from Algebra 2 and Algebra 1. And what we're going to do is we are actually going to create a completing the square type problem. The reason why I want to do that is because I need something squared plus a number squared. So I'm really not changing the problem, and I'll explain why that is by writing this out the way I have. What I'm doing is I'm going to complete the square here, and so I'm adding a box. Now if I subtract that same box off the same bottom, I have not at all changed the problem. So I want to subtract off the box, and I added a box, and I subtract off the box, so these would just cancel and I get back to where I started. If I complete the square, I take half of this and square it, so half of this is 2, and 2 squared is 4. So I'm going to put a plus 4 and a minus 4, so now that there's actual numbers in there, you can see I haven't changed the problem. I could just cancel these. Of course, I don't want to do that because it puts me right back to where I started. So what I'm going to do now is I'm going to rewrite this. And I'm going to put this as x plus 2 quantity squared plus 9. Well, now this is looking more like a arctangent because I have something squared, an x squared, plus I can make a number squared and a squared out of it. Alright, so I now can see that I can make my u be x plus 2, and my du would be just dx. I'm going to go back up here and I need to put some dx's on these. So I'm going to rewrite this. A faster way to probably do this would just be to change those definite integrals. So I could put negative 2 in here and I'd get 0. And I could put 2 in here and I'd get 4. So I'm going to change those. This would give me 1 over u squared plus 3 squared. Come up here, I'm ready to integrate. The integral of tangent or arctangent looks like this. You put 1 over, this is arctangent, the A is 3, arctangent of u over the A, which happens to be 3, and then we put plus c, but since we have a definite integral, we have from 0 to 4. So this is going to give me 1/3 arctangent of 4/3 minus the arctangent of 0. Well, 1/3, let me go ahead and simplify this. Arctangent of 0 is 0. And so my answer is just 1/3 arctangent of 4/3. Going on to another problem. I may not get this completely finished in this video, so I'll finish it up in the next one. Again, I'm going to want to, maybe I could just pick this as my u. Maybe I could do that. I'm going to try that. X squared plus 2x plus 2 du is equal to 2x plus 2. Almost what I needed. I needed 2x minus 5. Well, that gives me an idea. What I could do is go ahead and keep this as x squared plus 2x plus 2, but just change the top. So I could get a 2x plus 2. Now, how can I do that? Well, I still have to have this minus 5, but if I add 2, I can also subtract 2. So I'm going to highlight these because I could actually get rid of them and they'd create 0 and I'd go back to where I started, so it's a completely legal thing to do. What that allows me to do is rewrite this as 2x plus 2 over x squared plus 2x plus 2 dx. Okay, I'm going to repeat myself just a little bit on this. I was just getting ready to separate this a bit. So I talked about how I could add 2 and subtract 2, which would create 0. So that's going to make me be able to have this nice U statement, and this integral is going to come out really nice. This other one, what I have left with is a -7, because -5 and -2 makes -7, over, I have this x squared plus 2x plus 2 dx. Now this is still messy, but I should be able to use a completing the square type method and then be able to make some sort of arc out of it. So what I'm going to do is I'm going to rewrite this first integration using this u statement up here. So I have u on the bottom, and I needed a 2x dx, or 2x plus 2 dx, and I have exactly that. So this one writes out very nicely. This one I've still got to mess with, though. I've got a -7 over, and you know what? Let's go ahead and get rid of that -7. Let's just pull it out of the way. So I've got a 1, and then I have this x squared plus 2x, and this is not going to make, it's not going to be able to be factored right now, so we're going to complete the square on it. So I'm going to put plus a box, and there's my plus 2, and then I want to subtract that box off. What goes in the box is half of this squared, so that would be 1, and then that's going to give me -7, the integral of 1 over x plus 1 squared plus 1. Now I have a u squared plus an a squared. That is an a squared. And I can just copy this stuff down. And I'll have to come up here to finish this. I'll see if I can squeeze this in. Well, the integral of 1 over u would be ln of absolute value of u. And then I'd have -7. This is arctangent. Arctangent says that you would write 1 over my a. Well, the a is just a 1, so that's why I can just put -7 over 1 is not necessary. And then arctangent of u over a, so the u over a would be x plus 1 over 1 again, not necessary. And then I need to just put my plus c. So my final answer is going to be ln of absolute value of x squared plus 2x plus 2 minus 7 arc tangent x plus 1 plus c. And I didn't really squeeze that in very well. Go back and look at the integral of arctangent. You should be able to see that much more clearly. One more example. I'm trying to get through this one. This one again, I'm going to bring this 2 out front. Nothing's going to work again, so I'm going to have to figure out some way to complete the square. I'm going to pull out a negative because I don't like to complete the square with a negative. So I'm going to pull out a negative, which would make that -4x. So now I really have 1 over negative. This would be x squared minus 4x plus a box. And now I'm going to, underneath that square root, subtract the box. Put a 4 instead accidentally. Now I have to be careful because I really have a negative box. And so I really want to make that plus a box. So I have a negative box. And so I want to add the box back on. Half of this squared is 4. So I'm going to have a 4 outside of here. So what I really have is I have the integral of 1 over, I'm going to rewrite this, put the 4 up here, so I have 2 squared minus, I can get rid of that minus here, and then this factors into x minus 2 squared. Now this happens to be arc sine, so my u is the x minus 2, and because my du just ends up being a dx, I don't need to make a u statement. So I'm just going to say 2, this would be arc sine of u over a, my u is x minus 2 over a, which would be 2, and then I'll put plus c.